Okay. Hello, Meryl. Hello, Sergio. We'll get started in another minute or two. We'll give some other folks time to click and log on.
And while you're doing that, if you want to put in the chat where you are calling in from today, that would be amazing. And then if you need live transcript or want the transcript for this, you can just click down below on the CC and it will open up the transcript for you. Unfortunately, it's just in English, but it'll help if you're interested.
Oh, nice. Right where our a lot of people live along Sligo Creek there. One of my best friends lives along there and likes to use those trails a lot.
What do you think, Mary?
Sure, we can get started because again, it'll be recorded. We'll remind people at the end that it was recorded so they can go back and watch anything they missed.
Awesome. Well, thank you all for being here this afternoon. Nope, this evening. I never know what time of day it is anymore. I'm just sitting here for so long. But welcome. My name is Larissa Johnson. I'm the Residential Energy Program Manager for Montgomery County Department of Environmental Protection. October is Energy Action Month, and this year our theme is Electrify Everything. So we are in the final stretch, which really we kind of did on purpose because it coincides with all those leaves falling onto your yard. So this week we are focusing on electrify your yard, electrify your lawn, and we have an amazing special guest that is going to talk to us about electrifying everything in said yard, said lawn. So I am going to turn it over to Mary first because she works with the Department of Environmental Protection, and I want her to tell you what she does, and then we're going to introduce Jamie. Dr.
Right.
Banks.
Thank you, Larissa. My name is Mary Travellini. I also work in the Department of Environmental Protection for Montgomery County, and I'm the Organic Lawn and Landscape Manager. Part of my job is to educate and enforce our county pesticide law, which applies primarily on lawns, but also in some other spaces in the county. And then I also do work around some of our tree planting programs and our pet waste station installation program. So lots of things overlap with energy when it comes to the great outdoors, and we're happy to have Jamie tonight, and Larissa's gonna pass it back to Larissa.
Oh, passing it back to me, and I'm passing it over to Dr.
That's
Banks.
right.
Yeah, so I will let you introduce yourself and what we are doing today.
Okay, well, thank you. Thank you for having me. Thank you, Mary, for the invite, and Larissa for your assistance. My name is Jamie Banks. I am the founder and president of a national nonprofit organization called Quiet Communities. I'm going to talk about Quiet Communities a little bit in the presentation, but just by way of background. I was a healthcare researcher for many years. I worked in the field of health economics and health outcomes, but brought that lens to looking at environmental issues and environmental health issues back in 2007. In 2013, I founded Quiet Communities because I was very concerned with the proliferation of gas-powered lawn care around our communities to an extent really not seen in the past. And basically many of the tasks, if not all of the tasks that were once done manually, were now being done with gas equipment, including two-stroke engines. So I'm going to present today on some of the impacts and some of the solutions and what the industry is facing today in terms of challenges to transitioning, so that we can all have an understanding that this is not just a silver bullet or a snap of the fingers. It's something that really deserves careful consideration and proper resourcing. So with that, I'll share my screen. Okay. So I titled this Electrify Everything in honor of your weeks of events, but I said including leaf blowers, and really we can talk more broadly about the gas land care industry in general. I mentioned Quiet Communities as a national nonprofit, a 501c3 organization. We have a number of programs, but our oldest program is called Quiet Land Care, and its mission is to transition landscape maintenance to low noise, zero emission practices to protect worker health, children's health, and the health of the public and the environment. We are a coalition mainly of scientists, medical physicians, and legal folks, and then some community members as well. And we take a scientific, evidence-based approach to looking at the problems that are facing us and developing systematic approaches to those issues. I'd like to say before I talk to this slide that we collaborate in the land care area with an organization. It's the American Green Zone Alliance, also known as AGZA, A-G-Z-A. We've been working with AGZA now for about 9 years. They're a global leader in helping the industry transition and have a number of programs directed at certifying workers in handling, operating, and storing and charging and so forth, battery electric equipment, including robotics. And we have partnered with them on a number of things, including planning what's known as the AGZA Green Zone program, which I'll talk about in the presentation, certification training, procurement specs. We actually developed for the state of Massachusetts the first technical specification for commercial grade battery electric equipment, so that state agencies, public universities, municipalities could confidently buy off of that contract and know that they were getting quality equipment that could do the job at a commercial scale. We also organize and collaborate with others on research. We've done that with Harvard School of Public Health. We've done it with a big engineering firm looking at characteristics of noise of lawn and garden equipment and what makes it so disturbing to communities. And we do a number of other things as well, including expert testimony. The reason that there's a carrot and a stick here in the middle is that we agree that reasonable legislation can be a good push, but we really emphasize a carrot approach, having a pull or incentives to draw industry into wanting to use and then practice with low impact alternative equipment for land care. I'll start with the impacts of gas equipment. Gas equipment has a lot of impacts, certainly at the level of use that we see today. The health impacts include dangerous noise levels far above occupational safety standards. And I think we know that many workers today are not using proper protection and really putting their hearing and health at risk. There's toxic and carcinogenic exhaust that comes out in the form of what's called volatile organic compounds, including benzene. This combines with nitrogen oxides to form ozone, which has adverse health effects. including lung and cardiovascular effects. There's ground source particulates, all the stuff that's blown off the ground. Now, the danger from that is going to depend very much on the surface, the particular surface. If you're blowing on shoulders of highways, it could include heavy metals like lead. If you're blowing on a lawn, it could include things like pesticides, herbicides, other things which are not good for our health. For workers, gas equipment vibrates a lot, and this can cause damage to hands and arms and also whole body. And that damage, it's neurological damage, it's irreversible. So workers are at risk from that. And then they also handle a lot of solvents in the course of maintaining and refueling equipment. So that exposure is also constant exposure and inhalation of things that are not good for health. In terms of environmental impacts, those same air toxics can be also toxic to animals and not good for our plants. In fact, ozone is, I believe, one of the major harmful air pollutants for plants. You know, just the kinds of plants that we're trying to maintain and beautify, and yet this equipment, if it's producing ozone forming exhaust, can harm those plants as well. It's also a source of greenhouse gases, especially mowers that have had a lot of the toxics cleaned up, but produce most of their carbon in the form of carbon dioxide. And then toxic non-recyclable waste that comes from a lot of the maintenance of the equipment and worn out parts. These chemicals, detergents, lubricants, etc., come in non-recyclable plastic containers. They may contain toxic residues, and these get thrown into our landfills where they can contaminate soil as well as eventually aquifers. There's also a problem with fuel spillage. If not very carefully done, every time you refuel, there can be a little bit of fuel spilled into soil or near water sources, and this can be very substantial in the aggregate. Of all the equipment that's out there, all the gas equipment, it appears that the leaf blower, the gas leaf blower, is really the most egregious. Many, many communities are distressed, and when you think about it, why is that? What is it about blowers that's so distressing? Well, they're used frequently, or at least regularly, often for long durations. There's communities where they can hear this noise, smell the emissions hours at a time. There's often multiple blowers used simultaneously. 2 commonly, but anywhere up to 6, even on small properties. We've seen or heard from communities, have seen pictures and videos attesting to this. These machines are also constantly throttled up and down as they operate, and when they're not running, they're idling, and you can hear them idling. The sound has a strong low frequency component. What I mean by that, it's like a bass component that has a vibrational quality, and I'm going to tell you why that's important in just a moment. For that low frequency sound, a lot of hearing protection is not sufficient to drown out that sound. And there's really an inability to control it or get away from it if you're a resident in your home. You can hear it come through walls and windows. For all these reasons, over 200 municipalities in the nation have enacted some type of restriction. There's also states and counties that have enacted restrictions, so it's quite substantial, and there's many more trying to enact restrictions. So I mentioned this strong low frequency component that is typical of gas combustion engines. That low frequency component looks like a shallow wave, like you see in the illustration here. It carries harmfully loud levels of noise over long distances. And again, that sound, that low frequency sound, can readily penetrate walls and windows. Just like you hear from a boombox in a car next to you, often it comes right into your car as well. So what are the implications of that? The low frequency component is something that's missing from electric blowers. If you have a gas blower that's 65 decibels, that's relatively quiet for a gas blower. The really powerful ones range typically from 75 to 83 decibels, which is 2 to 4 times as loud as this quieter 65 decibel blower. But my point here is that you can have a gas blower and a battery blower that are both rated at 65 decibels at 50 feet. And yet, because of that low frequency component, that sound from the gas blower is going to travel at a louder level over a longer distance and affect many more houses in an area. So that's really what this illustration is about. So there's many good reasons to electrify. Having battery electric equipment do maintenance can bring better health and improved quality of life for both workers and the public. It can result in a cleaner, quieter environment. It's better for ecosystems, and there's cost savings if properly handled. This comes from avoided fuel costs and reduced maintenance costs. And it can also help to grow a clean, green job sector. But the industry is facing a lot of challenges. It's looking at a future that looks nothing really like its past. And this is because of the emergence of all of these technologies. It includes different sources of energy, solar and wind, of course, electric motors and electric batteries, software and data analytics, robotics, and all of this transition to a future that looks like this has to happen while customers are satisfied, while companies are getting a return on investment, and so forth. And there's also issues having to do with battery recycling. How is that going to be handled when this industry really starts to grow? It's the same problem with electric vehicles. There's barriers to any new technology adoption. There's a learning curve. There needs to be awareness by the industry, education and training. This industry happens to be really deeply entrenched in fossil fuels. It's used gas combustion equipment for a very long time. There's different political and regulatory factors involved. There's technology barriers. Even if you want to start an electric fleet, you also have to look at things like your electrical infrastructure and storage facilities to make sure that it's properly circuited so that it can charge things safely. And so you can store batteries and equipment safely. There's the cost. The upfront investment for battery electric equipment is higher, quite substantially higher. Upfront, even though downstream, because of that avoided fuel and reduced maintenance, you're going to be able to make up that difference and eventually be more profitable or benefit from those savings. And there's just cultural and behavioral issues having to do with not wanting to make change, not wanting to get away from what you're used to using and comfortable with. So in addition to those barriers, we have to recognize that there's a whole system here. It's not just the landscaper. It's manufacturers, it's their associations, it's government entities, it's customers that want certain aesthetic, it's concerned citizens that are pushing for change. So there's a lot happening in this system and a lot of things that are influencing attitudes and willingness to change. You know, and those include things like the health and environmental impacts that are driving people towards asking for change, but then there's things like economics and cultural things that are factors that need to be considered and overcome. So we really need to look at this from a systems perspective. Specific transition considerations for industry include that As I just mentioned, this is a very different technology platform than the internal gas combustion engine. There's a different model that's been developed over the decades, and it's one that is really based on going quickly from house to house to house, or doing land maintenance very efficiently in a municipal setting or a corporate setting. Equipment selection criteria really refers to being able to select the right equipment to do the job. I mentioned that there's commercial grade equipment, there's residential grade equipment. We know that for commercial entities, they need to get equipment that's going to be able to do that commercial scale work day in and day out. It has to have structural integrity, certain run times, certain charge times, and so forth to really meet those requirements. There's work productivity issues, and especially with leaf blowers, they are just not as powerful. So given the current business model where revenues are based on the number of homes you can get through, having something that's not as powerful is going to slow you down. And so there will be a revenue impact. So how do you make up for that? We're going to talk about that in just a minute. Storage and infrastructure needs, I just mentioned. There are safety issues with batteries as well. Batteries can catch on fire if there's thermal runaway. We know that a lot of the manufacturers have their batteries certified and so forth to put them on the market, but still these are issues that need to be considered. Safely charging and storing batteries is essential to maintaining worker safety. Battery and repurposing, we just discussed. What are we going to do with all of them? Do the manufacturers have take-back programs? How can batteries that lose their power for this purpose be repurposed for other purposes, like things like solar storage? Can they be recycled? The higher upfront expense, how are businesses going to come up with that extra money needed to make that investment? And then how soon can they get a return on investment? So focusing again on commercial electric blowers, there is this important consideration that I just touched on, the fact that they are not as powerful. And so for companies, for municipalities that we've worked with, this has really been the sore point for them. They'll say that it's not as powerful, they just can't do the job that they did with gas in the same amount of time. So to make this successful, there really have to be other adjustments made. When we think about electric blowers and the economics that are involved, we considered three models. A conventional model where we're looking at blowers, electric blowers, really having to do the same job as gas blowers. This would be a situation where a customer is demanding a very highly manicured aesthetic. They want those blowers used year-round to maintain that, even through the winter. Where there's some snow on the ground, they want their pathways cleared, etc. There's a transitional model that has more judicious use of blowers, and where things like mulch mowing and other low impact practices are used, the aesthetic expectation is less formal. And then finally, going even further, there's an ecological model that we consider where there's a variety of practices integrated in routine maintenance, and the electric blower is really only used where absolutely needed. These models are simply models. They may not reflect any one reality, but they're very useful from an economic standpoint to understand what the implications are. A conventional model is going to require contractors to invest in the greatest number of batteries, and those batteries are expensive. Whereas as you move to the right through the transitional and ecological models, they're not going to have to buy as many batteries, so that upfront investment is going to be less. What this means is that the conventional model, the time to getting a return on investment is going to be longer, and for the ecological model at the other end, the shortest amount of time. So how can we make this transition? This diagram is really an illustration of a situation where we're expecting landscapers to take on this burden of investing and changing their practices. So we know that there's high upfront costs. Something we haven't mentioned, there's supply chain issues to consider. So just like other industries, this industry has also been affected by supply chain issues, battery shortages. There's the work production losses because of the less powerful blowers. And for other pieces of equipment, there might be slight losses in work production as well. What we'd like to see is that this becomes a fairer and more equitable situation where residents can understand the economics that landscapers are facing. For instance, if you're going to demand a manicured aesthetic, you really should recognize that the investment by the landscaper is that much higher. There may be a premium for those services. Governments, local governments, county governments, state governments should think about supporting the industry with financial incentives in the form of subsidies, perhaps trade-in programs, other kinds of things that can alleviate the burden that would otherwise fall strictly on the landscaper. So it's about getting the right tools, it's about education and training, and then properly resourcing a transition. It really falls on all of us to help make this happen. So I want to switch gears a little bit. AGSA and Quiet Communities started a couple of years ago putting together an online education program that could help workers transition to these new technologies. Right now, we have an online course, we have several in-person courses and field training courses that are helping industry to make this transition. And I mentioned that making this transition is not easy. This illustration has 15 lessons, and it really goes from talking about the importance of becoming professionally certified and really learning about this new technology, to understanding the future, the impacts of gas equipment, and then of course how battery electric equipment works, how to operate, handle, maintain, charge properly, storage and infrastructure considerations, the battery cycle life and recycling, and of course, safety issues. So there's a lot to learn about this new technology platform that is really critical for workers to make this transition properly, safely, and profitably. Industry is recognizing that this type of education and training is needed. So our collaborator, AGSA, and the National Association of Landscaping Professionals recently entered into a partnership to work together to educate and train industry and help them to make this transition. So it's a big step forward. Other things that are needed: resident education, that they really understand what's involved in transitioning an entire industry, engaging all the stakeholders in the system, of course, educating and training workers, properly resourcing on the financial side, and then having influencers or first adopters or movers that can help pull others in this same direction. And I'll talk a little bit about this. Reasonable legislation. If you're going to have an ordinance, make it fair for industry so that they can make this transition over time in a way that's reasonable and doesn't threaten the viability of their business. And then public-private partnerships and alliances. One thing that residents can do to help the landscape industry transition is to actually purchase and store electric equipment at your home or in your neighborhood or HOA for the contractor. This is being done in different parts of the country very successfully. What I have on this slide is that if you are interested in doing this and don't know what equipment to purchase, there is a program that AGSA has started called AGSA Field Tested Certification. You can go to the AGSA website, which is agsa.net, agza.net, and you can find certified equipment on that site. There's things that governments, local, state, county governments can do, institutions, hospitals, universities, school systems can do, and businesses could do to lead by example. And one way in which we have helped to promote this is through something called the AGSA Green Zone program. And what you see here are pictures of municipalities that have implemented this program. What an AGSA certified green zone is a defined area of land that is routinely maintained without the use of gas equipment. And there's different levels, and I'll show you those levels. It's a structured program of implementation. It can start in a small park, a library, or other public building. But what it involves is a number of steps. There can be a transition or strategic plan that is involved where an entire municipality may want to transition over a certain number of years, but doesn't know quite how to go about it and what to prioritize. So in that case, there would be some kind of plan put in place. There's education of the crews in that municipality or institution. There's equipment recommendations so that they purchase counterparts of their gas equipment that enable them to do the job approximately with the approximate efficiency and aesthetic as they were getting with gas equipment. There's infrastructure and storage recommendations to make sure that they have proper electric circuitry and safe storage. There's field training, outdoor field training on the equipment once the equipment is purchased so that the equipment is put together in the right way, it's operated and handled in the right way, and there's adjustments made so that they can get that same aesthetic with comparable efficiency. There's also something that goes along with this called ELF analysis. ELF stands for Environmental Landscape Footprint. And what we do here is that we estimate the impacts that gas maintenance has. How much noise is produced, how much air pollution is produced at a very granular level, including ozone-forming chemicals and fine particulate matter, as well as carbon dioxide. How much fuel spillage happens, in the course of maintaining with gas equipment? What is the fuel consumption? What are those fuel costs, et cetera, and what is the toxic waste burden? So that's the kind of report that municipalities, institutions, or school districts would get with this kind of program. There's an economic analysis to estimate the time to return on investment, cost effectiveness in terms of dollars per ton of carbon saved, for instance. There's professional certification of workers, and then there's certification of the property that's becoming a green zone with a memorandum of understanding to ensure that this is maintained over the long run. And often there's a celebration that goes with this. It's structured to allow to meet municipalities, businesses, and others where they are. So level 1 is really phasing out all two-stroke engines for routine maintenance. This would be your blowers, your string trimmers, hedge trimmers, and so forth. Small gas two-stroke engines, and still allowing for that equipment to be used for things like heavy fall cleanup. So you can start with that, and then level 4, it's not only phasing out all gas equipment, it's also incorporating other practices like organic practices. So here's an example. The city of South Pasadena back in 2016 became the first municipality in the nation to become an exo-green zone city. The way this was done is they started with a small park, which is on the left in that little box. Garfield Park was a 5 or 10 acre park. That beta project was very successful, and based on that success, the city decided that it wanted to transition all of its municipal operations to battery electric equipment. And so it moved forward and did that. There's also things that can be done like trade-in programs. This can be done for residents, for residential equipment. It can be done also for commercial entities. And what happens in these trade-in programs is that gas equipment is brought in and it is swapped out for a new piece of battery electric equipment. It's really a subsidized purchasing event and can help businesses and residents save a substantial amount of money. And I think that's where I stop. So thank you for your time. I'm happy to answer any questions. And please feel free to reach out and contact me.
Thank you, Jamie. Does anyone on the call have questions right now? Go ahead, Meryl. Let's see.
Oh, Meryl, you're on mute. Can you unmute?
There she is. You're unmuted now.
Okay. So, can you explain a little bit to me about 4-stroke engines as opposed to the 2-stroke engines? I live in a condo community. We have 166 townhouses. When I said I live close to Sligo Creek Park, my community is 15 acres of the park, and our biggest issue is dealing with our fall leaves. We have tried very hard, and I think that we've had success in helping the community to understand that the leaves are not our enemy, that there are many good things about our leaves, but literally it becomes a safety issue in the fall with the amount of leaves in terms of our sidewalks, parking lots, and so on. But then also because we are so shady, if we leave too many leaves in our environment, then that basically is causing death of our understory and erosion problems. So is it worthwhile to look at moving to I think I have read that there are some 4-stroke engines for backpack blowers and so on, or am I wrong about that? And
No,
would
you're
they
not
be
wrong.
is that a better investment for our community? Because I just don't at this point that we're going to move totally to electric leaf blowers. I don't think that we would be able to handle that.
So there are 4-stroke blowers. There's also 4-stroke engines for some other equipment as well. You're going to they're much more efficient engines. They're cleaner engines. You're not going to get the emissions, the exhaust emissions that you get from a 2-stroke engine. On the other hand, they're not going to relieve the noise issue.
For the use of gas and oil and dripping and those sorts of things, right?
Yeah, and there are some 4-stroke blowers that are quieter, but they're not the most powerful ones that businesses tend to want to use. So every time somebody says go to, there's quiet leaf blowers. Well, there are quieter gas leaf blowers, but nobody buys them. The contractors don't buy them. They want those really powerful ones, to get through fall cleanup and so forth. But the other thing I can say to you is that when we use the term routine maintenance, we're not talking about heavy fall cleanups. And the good commercial battery electric blowers that are out there are really sufficient for a good part of the year. Certainly the summer, you know, a good part of the spring, part of the fall, and any, you know, winter, if you want to clear off snow dust or something, they are perfectly fine. It's really the heavy cleanups that pose a challenge.
Okay.
Yeah, and Meryl, some of the things to consider too is, overall, sometimes there may be a little bit of additional cost, but up until not long ago, a lot of those giant piles of leaves were moved by rakes. So a combination of using rakes, these, when Jamie says these are less powerful, they're not weak. They struggle when there's a big, heavy pile of wet leaves, and they're going to use up the battery faster. So depending how large the crew is, how many batteries they have, et cetera. And then also, are some of these things, can they be raked? And also, if the community is being vacuumed, can the piles be, where can they be brought to and in smaller piles so that the vacuums can suck them up without having to move them quite as far? So there's so many considerations for each site.
Mary, does your department do on-site visits to give recommendations to communities, or you're not quite that far?
It's not a standard, but I'd be happy to come by and kind of look at the site. I'm very familiar with that volume in Sligo Creek that happens in the neighborhoods and how tight your communities are for where you can put those piles. But sure, I'd be happy to make a site visit and chat about that.
Great, thank you.
You're welcome. Oh, Sergio, you're muted. Let's see.
Yeah.
There you go.
Sorry. Jamie, what's the difference in cost, roughly, for a electric blower versus a big commercial? Just trying to get a sense for the commercial guys. What's the delta?
So the gas blowers kind of run, $500 to $600 for a powerful commercial gas blower. The electric ones can cost, the backpack batteries, the price has really gone up, and they're, I don't know, $1,600 or $1,700 a piece.
Right.
So it's an expensive investment.
Right.
And, with fuel prices where they are, you are going to get a return on investment, but it's going to depend on, how often they're being used,
right,
and what that aesthetic expectation is.
Right. Yeah, because it'd be interested to actually get to a, 3-year or 5-year cost comparison. Just because it makes sense to people to do that. Yeah, the batteries are being used everywhere. So, that the supply chain issue is tough. Okay.
Yeah, no, we just did an economic analysis for a group of, I think, 11 communities in the Midwest, looking at exactly this. And, fuel price is one driver of that
Right.
return on investment. But the other thing is that aesthetic expectation and how intensively they're going to be used over the year. Yeah,
Right.
so.
And there's a balance too, and depending on the size of the fleet and how often it's used, et cetera, that, you've got the fuel costs, you've got the oil costs, you've got air filters, you've got spark plugs. And so you have maintenance that the electric blowers have no maintenance on them. So you're talking about in terms of time and efficiency of everything, in addition to the costs of all of those parts that you need to maintain, that should be done pretty frequently to keep a leaf blower happy and working.
Yeah, Jamie, has anybody ever done that analysis? Sort of a
Yes.
simple, it's out there. Okay, I'm gonna reach out to you for that.
It's not out there. We actually get paid to do it.
No, well, that's out there.
We try. Yeah, but you know, it's adopting electric blowers in for the current business model is really tough. There really needs to be an adjustment in how you practice land care and landscape maintenance.
Right.
You know, that you do use these supplemental techniques to help, you know, where the work production falls flat. What other things can you do to make up for that so that you can do this just as efficiently? And
Right.
there's, you know, there's resistance to this kind of change. You
Right.
know, the guys are used to hopping off the truck, turning on the machines and blowing everything away, but there's certainly other ways to do this. And there's companies that are doing that.
Right. Right.
Yeah.
Mary, is there training for people, companies like that here in the county?
We
Or-
don't have any current training set up. We recently did have a training. It was not the full AGSA
Right.
certification, but AGSA was here recently, and we're hoping that we might be able to find a way to get them, back where we could, fund it for landscapers to be able to come in and get that AGSA certification training. So we're hoping that down the line we can do that if we can find a way to fit, fix a budget to do that for our landscape communities.
Yeah.
Yeah.
And
Well,
that
I have a question. Does it look like Montgomery County is going to be implementing a ban on these gas blowers?
I can't
I heard
say
it
what,
those days.
yeah, I can't say what the future holds. I know that that there's a lot of support behind it, and there's a very good chance it will pass. But again, we've got new council members coming on, other ones rolling off. There's a lot of, but like I said, there's a lot of support behind it. So I would be surprised if there wasn't one coming down the line. But in terms of, crystal balls, I actually don't have any pulse on which way it's going.
Right.
But I would say that, for homeowners and landscapers, a lot of homeowners are already transitioning. So, and the costs are lower. Like when you compare a residential version, the costs are pretty close to equal,
Right.
sometimes a little more, a little less, depending what you get. But when it comes to the commercial, it's a little bit more of a struggle. So the residential folks have not had as much trouble. There are supply chain issues, but in terms of sales, if you go into the stores, that's what they're selling. That's most of what's going off the shelves. That's what people want. They're lighter, they're quieter. There is no maintenance. There's no gas fuel, to fill up. There's nothing. So residential, a lot of that conversion is not as big of an issue. So there's from the residential side, there's not a lot of push back, and even the commercial industry is moving in this direction all across the country. Again, they've got things like supply chain issues, they've got cost issues, but they know it's what is better for their workers, and they know it's quieter, and their communities and their customers are requesting it. And that's where some of the suggestions like Jamie had of having more folks have the equipment for their landscaper to use is going to help advance that, because a lot of times as soon as a landscaper starts using one of these, they're like, oh my God, I love this, right? Because their body isn't vibrating at the end of the day. And their ears are protected, and they don't smell like fuel, and they're not dripping in oils, and they're not pulling chains, to start it all the time. So the industry, I think, and correct me if I'm wrong, Jamie, is going in this direction. It's just that there's barriers right now to getting there quickly.
Jamie, a couple questions. Can you talk a little bit more about that 65 decibel thing that you talked, that graphic? I didn't quite get it. The second question is there a, in that program from South Pasadena where you trade in, from a recycling point of view, is there an actual, what happens to those machines? Do they get disassembled? Do they just get sold, to somebody, low income?
Yeah, so the Sergio, I mean, if Dan were here, he could tell you more because he's done, I think, over 100 of those exchanges. Dan made from AGSA, and California has had the benefit of a fund to do those exchanges. That is kind of unique to California. But what happens is that the gas equipment comes in, it's picked up by a scrapper.
Yeah.
So, you know, some of the metal is recycled to the extent that it can be and so forth. So that's what happens.
Right.
Yeah. Regarding, so the 65 decibel diagram that you saw, we did a study with a large engineering firm called ARUP, ARUP. We published that study actually in the scientific literature. And what we did, we had done a pilot study with Harvard School of Public Health saying, what is it about the noise from gas equipment that is really distressing people? And that pilot study showed that that strong low frequency component of the gas engines was carrying loud noise over long distances. But we didn't have a comparator in that to say, how does electric compare in that regard? So when we did the head-to-head study, what it showed again is that the gas equipment had that strong low frequency component that was missing from the electric. And so I'm sorry, it's a little hard to explain. 55 decibels is the threshold that is considered safe for 55 decibels and under is considered safe for health and hearing. And apart from hearing, there's a lot of impacts of noise on the body that are mediated by stress. So increased rates of heart attack, ischemic heart disease, hypertension, all of that is related to noise. So 55 decibels is what's considered safe. So in the experiment, we said, over what distance does sound at 55 decibels or higher carry from the gas versus the electric equipment? And so we did we tested how long it carried from a number of blowers, you know, a bunch over 65 decibels as well. But the really interesting finding was comparing two machines that were manufacturer rated at the same level, which is how loud is it at 50 feet? Okay, it's the same, 65 decibels, gas to electric. But how far does that 55 decibel or higher sound carry? It's a much longer distance with the gas than it is with the electric. The electric, you know, the higher frequency kind of looks like the stock market.
Yeah, yeah.
Know, that ragged.
Right.
It dissipates over a shorter distance. And that, you know, that shallow, low frequency wave travels longer.
Okay.
And it was really interesting. We've been doing this work for a long time. And I remember we were at one municipality and told them about this and said, it's also true of the mowers. If you put a large electric riding mower next to a gas mower and the gas mower goes off and, you know, a football field away, you can still hear that sound loud and clear. But the electric mower, as it moves away, the sound just goes down dramatically so that you can hardly hear it. Yeah.
Okay. It's good. Yeah. Awesome. Great presentation.
Thank you. I didn't quite know who I'd be talking to, but
yeah, thank you all. Thank you for coming. This is going to be recorded so that if you have folks in your industry or in your neighborhood that wish to watch it, we'll send it to you individually, but it will also be posted on our DP YouTube channel and on our website. You'll be able to get access to it. So you'll have that to share around. And I put Jamie's contact in the chat. So Sergio, if you want to contact her for further information, Larissa put my email in the chat if you want to contact me to come out and visit your community. Happy to go on a walk there with you or anyone else. And Jamie, we really, really appreciate you coming out. This has been fantastic. Larissa, did you have anything else?
Just always, if you are looking for information about what we're doing in the county around electrifying everything or lawns or watershed management, we usually post on mygreenmontgomery.org. That is our website for all things green in Montgomery County. So
Awesome. Great. Well,
Thank
thank you
you.
again. Really appreciate you all coming out on a Monday night. And thank you again, Jamie, so much. This is going to be really helpful. We can't wait to get this posted and have more people get access to this.
It's a
Thanks,
pleasure.
Jamie.
Thank you for
Thank you.
Thanks
having
so
me.
much.
Thank you. Bye now.